So let's look at trig proofs. Now before we start solving through some of these, let's look at some hints. There's just some things to keep in mind as we go through these. First off, you want to pick the most complicated side to work with first. Whatever has the most things there is actually going to be the easiest one to simplify, which seems counterintuitive, but we're going to see that as we go on. Not necessarily always, there's always a more complicated side, but if something is equal to 1, you want to take the mess that's on the other side. Work just from one side. Do not move any terms across the equal sign. So this is not solving an equation. If I had something like x plus 2 equals 5, you would subtract 2 from both sides, moving the 2 across. We're not going to do that here. We're going to pick one side, and you stick with that one side until it matches the others. Factor when possible. This is thinking like a GCF. If I have sine x cosine x plus sine x, I want to factor out a sine x from both terms to leave me something like that. So factoring when we can. If the denominator of a fraction consists of only one function, break up the fraction. So if I have cosine x plus 1 over sine x, that is two fractions. It is cosine x over sine x plus 1 over sine x. And writing it as those two fractions may help us along the way. If there's squares of functions, look for other forms of your Pythagorean identities. We have sine squared x plus cosine squared x equals 1. You also have the one with cosecant, cotangent, secant, and tangent. Those may help us. Those are going to show up when we see squares, and especially like a squared plus 1 or a 1 minus a squared. Those do, we see those. Change everything to sines and cosines and simplify. That is a nice thing we learned about when simplifying the trig expressions. Sine and cosines usually help simplify. Combine fractions with a common denominator. Almost like 4, if we did the opposite idea. If I had cosine x over sine x plus 1 over sine x, I can make that into one fraction. And avoid the introduction of radicals. Don't take the square root of things if there's not already there. We don't want radicals. Maybe if we start with one, that's okay. We'll have to simplify through, but don't bring them in. So with that, let's start working through some of these, some examples before you go off on your own. So first one, I have tangent theta equals cotangent times tangent squared theta. More complicated side is going to be the right-hand side, so our goal is to simplify it down so it matches tangent theta. So if I first look, I see that cotangent theta is 1 over tangent theta times tangent squared theta. So I've done that step. Now, since this is multiplying and I have a fraction, I can make this tangent squared theta over tangent theta. Since I have two tangents on the top and one on the bottom, I can divide or reduce it down, and it's going to be tangent theta. To bring that down, we can now say that tangent theta is equal to tangent theta. This is not much different than what you did about the simplifying expressions. The nice thing is we know if we start with this, this is the goal. You just have to show each step and how you get to it. Now they match and you're done. Be sure you're showing each step as you work your way through. Okay, next one, let's go to 1 plus tangent squared w times cosine squared w equals 1. Our goal is to get 1. We do not want to take 1 and make it into this. Our goal is to take this side and turn it into 1. So first thing I see is 1 plus tangent squared w. That is a squared, it's adding 1. If I go look at my Pythagorean identity, it actually tells me that this is equal to secant squared w. So secant squared w times cosine squared w. Secant is 1 over, it's a reciprocal of cosine. So now we have this statement, which is actually looking pretty good if we look at our eventual goal, because these can become one fraction. And that turns out to be that 1 is equal to 1, and there's our proof. Okay, next one, I have a fraction on the left, cosecant, and cotangent on the right. I'm going to think on the left-hand side because this would be kind of tough to make into fractions. So let's look over here, start with the fraction and see if I can work my way to it. Now this was one of the hints I mentioned, that if it has a single term in the denominator, you can split it. So we're going to make this into 1 over sine x minus cosine x over sine x. Anytime you get a fraction, it's going to be easier to work away from the fraction to get to this. Now sine of x in the bottom leads to a reciprocal. The reciprocal is cosecant x. And now we're going to take care of the other fraction. Cosine over sine is the It's going to be cotangent. So now that I have cosecant x minus cotangent x is what we wanted. And we have a matching statement. Under our next one, secant x cosecant x over cotangent. So instead of splitting the fractions, which we can't really do here, I'm just going to write this out as a single line. So it's secant x times cosecant x times 1 over cotangent x. Now, secant x times cosecant x times tangent x is where I get next, and that's just using the reciprocal. I'm going to turn now everything into terms of sine and cosine. Secant is 1 over cosine. Cosecant is 1 over sine. Tangent is sine of x over cosine of x. Now, since this is all a fraction, it's like we're drawing them straight across, and we can reduce down because we have a sine on both the top and the bottom. So that's going to leave me with 1 over cosine squared x. Now, cosine squared x is the reciprocal for secant squared x, which is what we started with right up here. So secant squared x equals secant squared x.